Okay, so hello, my name is Lech, as I was announced, and today I'm going to tell you how to get started with Frege. So the first most important thing you can learn here is that's not Frege or Frege, it's Frege. It's name of a German philosopher and mathematician. And he was talking about and writing about higher order functions back in the 19th century. So just 30 seconds about me. Currently I'm a Scala developer, but I was a Java developer for a few years with functional inclinations. So I have used Lambda J in 2011, I think. Always liked it. I have some experience with Erlang also. And just because I like this functional programming, especially Erlang, but I had some problems writing my code with no help of compiler, then I have seen Frege, so JVM, which is my background, was there, functional programming was there, and compiler help built in. So I thought it's a good thing for me to dig in. So Frege programming language currently is announced as a Haskell for the JVM. It's a little bit change of direction because when I have first seen it, it was a JVM language in the spirit of Haskell. That's because there is ongoing effort to be on par with Haskell 2010 report, which we can consider as some kind of standard, at least this documented standard. I don't mean that, let's say, some industry standard is Glasgow Haskell compiler, which has many extra features that are missing in the report. So project is to check out from GitHub. There is a link in the bottom. And for those who don't know Haskell at all, there will be a first part. It will be a introduction to the language. It will be just a few minutes. And then I'll try to implement a JSON-linked web service using Frege and a few other things. So this will be a web service for validating JSON. And this talk is introductory. There will be only one part. I will go into more details. It's interoperability with the existing JVM code. So the features are language is purely functional. I won't go into dispute what does it mean. It supports higher order functions. Evaluation, like in Haskell, is not strict by default, but can be forced to be strict. Values are immutable. That is very important feature because we are in the JVM, which has no such constraint. And there are algebraic data types. Typing discipline is typing is strong and checked during compile time. Compiler helps with type inference, and syntax is terse. Keywords are short. There is few of them. And these two features in the red are key features of Frege. This language runs on the JVM, and it's interoperable with other JVM languages. So you can use existing code base with some restrictions. It's not like using Java in Groovy or in Scala, where maybe collections are different. We need to watch out for some constraints, especially this immutability and if code is side effecting, that are things that matter. So to get started with Frege, you first download jar from Maven or from web page, set up some aliases in your shell, and you're ready to compile. We won't download it now. We'll go into REPL. Project comes with REPL from this same GitHub organization. Believe me, if you copy and paste these lines, you will have REPL running. And maybe it's a good time. There will be just a few minutes of coding. How does this language or Haskell-like language look like? So our functional language will define first function, or I will declare that I have got function from int to int, which maps to a Java int primitive or integer type if we consider the size, the range of numbers. Compiler complains that we have no implementation, and that's it. That's the basic syntax. You can make it even shorter. You don't have to provide a parameter if on the right-hand side of equal sign there is a function of one argument. That's add2 function, obviously. And language is strongly statically typed, and if I would like to add this number, compiler complains. So sometimes you need to help get proper type or a type class in this case. So here I need to convert this 3 to the number or numeric type class. So now this function add3 finally supports all numeric types, and I can add something other than integer. And last of our live coding will be a greeting function. So I think we are within JVM language, so we'll greet Duke. And if you look at the return type, it returns IO monad of unit. And I have told you that this talk is introductory. There will be a link to a book for people who don't know Haskell. This language is purely functional. So in fact, greet function returns unit, nothing interesting, and it executes within IO context, so it is side effecting with the real world. So this real world is my console in this case. And REPL also comes with a few handy things, commands. First one, it's to check type of some function. That helps a lot, especially for the beginners. We can check, we can see documentation that comes from the doc strings in source code. We can see that's second most important thing today. We can see source code generated that's the Frege source. That's Java source code that is generated by the Frege compiler. So Frege compiles to Java source code and then runs Java-C with this code. So language itself, or the Frege compiler uses Java compiler. It does not create bytecode by itself. So all optimizations which are within Java-C are ready to use. And code begins with annotations, because you know that Java type system is not as powerful as Haskell is, or maybe you don't, but that's the fact. So code starts with a load of annotations which are used only by a Frege compiler and are not relevant to Java. And now the part of code you see is a Java or Frege runtime code. Yesterday in the evening, Ingo Wexung, the creator of the compiler, has given me a message that's new version from GitHub compiles, and the code is more, it's better, the Java code is typed better, because, for example, if you look at @3, it returns object, and that's not very handy if you want to use Frege from Java. But there is improvement. If time allows, I will show you difference. I have got 2 files prepared. Just a few seconds with other features of language. Here are how higher order functions looks like. So in the top line you see that this higher order function, I have given this name to show the feature. It takes function as first parameter, function as second, and can return function as result. Or you can even supply one more parameter, then it will apply the resulting function. So this is like partial application, it's sometimes called this way. We have got list comprehensions, very well known from other languages, almost like in Erlang, like in Haskell. Language is lazy by default, so I can use this constant function and, for example, print it in REPL, because REPL needs just first 80 characters or something like that. The computation will terminate. We won't get hanging REPL. Pattern matching with many clauses and algebraic data types, by the way. Guards helps with shorter syntax. Where clauses, let expressions to make code more readable, or don't duplicate sometimes some parts of code if you want to have it in a little scope. Do notation for monadic expressions. And finally, there's this not so quick sort. I think I won't skip showing how it works in the REPL, but there is one more thing REPL comes with. It can load some file. This is that's just this file I had open in IDEA a few seconds ago. So you can also write your scripts and play with them in the REPL later. So we know just the basics now, and we can attack our problem. We want to make this JSON-linked service. So first thing which we need, oh, sorry, I was quite too quick. There is an online RIP also. It's a, if we are still talking about tools, you can prepare some script in this upper left-hand side window, and it depends from which side you look like. And you can call this code in RIPL window on the other side. There is one thing also useful when you learn this language. It's a search engine for functions which you feed with type signatures you are looking for. I really like this this tool. It's called Hugel for Frege. Formerly it was Frugel, and now it's hosted, as you can see in this link, on haskell.org. Very useful. So we can finally parse our JSON to make the validation, and our first attempt will be quite like cheating, because we use built-in JSON library. There is a built-in library. For this, I will just explain this slide a bit. I import this data.json module with functionality I need. I make type aliases because I would like to see that I use this string as an error message, and validate is a type alias which takes string containing JSON or malformed JSON, and it returns either type, which which usually can have value left and right. So usually use left for signaling some error, and right if everything went okay. That's common use case for the either type. The function parse to value, it looks quite dummy, because it just equals another function, but I have reified the return type because the original parse JSON function is more powerful. It can parse string to many different types. The type just have to be instance of some type class. I don't remember which one, but I only need to parse to JSON abstract syntax tree, so I know if the parsing is okay. I know that the syntax of JSON was good. So whole logic of our validating JSON, this is a parameter. It's calling this parse to value function, and if our library returns some error, I just map it as the same thing, identity, and if it parsed to some JSON AST, I would like to return string representation. So show function gives me this string representation. But usually, when you would like to solve some problem with Frege, you won't have your library in your desired functionality in standard library. So let's assume we don't have this JSON library, and we would like to use some existing code from Java, some other Java library, and in this case we'll use JSON JSON module. So to call this JVM from Frege, we need to declare, we need to use native declarations. So we need to specify what classes we would like to use. If instances of these classes are immutable, like because in Frege we require that values are immutable. If they are not, there is one feature which helps us. I will get to this. And what's purity level of function? So if the function is really pure function, or if it changes some state, or if it have side effects reaching some network, disk, or other stuff. And there is also common that Java functions returns null or throws exceptions, and we can specify that also within this native declaration. So there is a compiler magic which helps us. So because my background is mostly Java developer and not so good at Haskell, now I will write a tiny Java wrapper which allows me to have a pure function to be easy for use from Frege. So I create object reader R. This type object reader is immutable. I have checked it. And I declare function parse, which parses string, and if it's okay, it returns this JSON node. If it's not okay, I map two kinds of exception into illegal argument exception. So the parse function is almost pure because it returns JSON node type, but it can throw exception. And without using Frege runtime here, I had no other option to solve this. And that's the Frege native declarations, which allows us to use this tiny wrapper. In the top, there is a declaration that there exists JSON node in confaster XML JSON data bind package, which is immutable. So there's this pure keyword. And it has got pure function to string, which gives me a string representation of this JSON abstract syntax tree. I declare that there exists getMessage function, which is pure, by the way, on the illegal argument exception type, which returns string. And I declare that there exists this pure native function com github lglo JSON wrapper parse, which I alias as parse. I need fully qualified name because this is a static function. And that this function takes string as parameter and it returns either illegal argument exception or this JSON node type which maps to JSON node. So is that clear? Or okay. So having this parse function declared that it exists in some library, compiler will check it for me. I have now my version 2 of validate JSON, which is very, very similar to what we had before. I just extract message in case of exception because I'm preparing the web service. So in the output to the user, I will present string finally. And in case I had this JSON node, so the parse was okay, I just used toString method from this JSON data type. So differences are very, very small. And this is this part I told I will go into more details, this native declarations, because this is glue which is really important, especially in the beginning. There is an easy case when you deal with pure types, which are uncommon in a JVM world. If I have created this rational data type which has final fields nominator and denominator, and it just represents rational number. So all functions are pure. Everything is, I think it's quite readable what's going on here. There is just this division function. I have prepared two versions. First one which throws if the second parameter is 0, and the last declaration is for the method which can return a null if you pass 0 as second parameter. In Frege, there is no null. You are not allowed to let null escape from Java realm. This is one of the iron rules you cannot break, because then everything just can happen. So if you declare using function which returns null, you wrap the return type into maybe type, which is like Java optional or Scala option. And in case your code throws exception, you can use either function. There is also a second option with throws declaration you can catch later, but I think this is a cleaner way. So native functions are, in fact, Java functions, and so they are strict on all arguments. And because Java doesn't know type classes, they cannot have such type class constraints. Okay, and I have created another dummy type. It's AB. As comment states, A is final, but B is not final integer. So type object of instance of AB is mutable, in fact. Someone can mutate this type from another thread if it obtains this reference instance, and I lose this possibility to reason about the value in each point of time. It just makes things harder to reason about. It's not. It doesn't allow me to think purely functional any longer. So the constructor, this native new, returns st is a state thread monad, which denotes that something can change, involve some state changes, and there's a thing that is new in Frege, which does not exist in Haskell, is this mutable type. So mutable types are a compiler defense for Frege. If you know that some type can mutate and can be used by functions which take mutable instances, you need to wrap your type into this mutable. So when you obtain such instance, you always get it into you have it in this mutable, and functions, Java functions which are not pure, are only allowed to take parameters also wrapped in this mutable. So we cannot mix mutability and immutability, but this is a very strong constraint, and there are methods to bypass it. There is a read-only function which allows you to extract this immutable part of your otherwise mutable type. So we can extract A from our AB type because it's final and it's quite safe operation. We know it won't mutate under the hood by another thread or anything like that. And there is also a freezable type class, which instances are able to create copies which are immutable, in fact. And tau function takes this immutable copy and returns something, some copy that is again mutable. So you use these functions if you need to deal with non-pure Java functions. And there is one last thing related to mutable. Sometimes you deal with types that are, let's say, highly mutable. They operate with real world, and you would have to write this st-mutable real world thing in type signatures everywhere, or on the left-hand side you would need to write a mutable real world parameter and so on. So if you declare this whole declaration as mutable, it compiles with the same constraints, but you are just you're not forced to type everything within this declaration, which helps with readability. But you are restricted to IO monad, which is for performing such unsafe operations. Okay, there is a tool for generating big amount of code, big amount of native declarations. You can feed it with some Java package or one class or package, and it will declare this. It will generate these native declarations for you. So workflow is as follows. You need to edit special file type properties. There is a little excerpt from this file. So big integer is, I declare it will be a pure, and it will be renamed to integer. Byte buffer is a class which is stateful, but it's not performing unsafe operations in real world. But file channel performs such operations. So there is a support in some plugins for using this tool, but I think it's more a use once tool. If you have got some library you would like to use from Frege, so you edit this file, declare which classes are pure or stateful or IO, and run this tool. And then it happens you have to wrap some return types in this maybe or either. If functions returns null or throw, fix some other return type issues they happen, mark pure functions as pure, and if then something does not compile and is not essential for you, you usually delete it. And the example I had before can be made with this native declaration without any Java wrapper now. So this whole presentation and all code is available on GitHub, and you will find submodule pure Frege with this code. So from this here we have no Java wrapper, just pure Frege. And things change a little bit. this is that are most in the top. There are most interesting parts of this auto-generated and then cleaned by myself native declarations. So there is this object mapper, which is mutable, and object reader, which is immutable. So it will be quite easy to use. And when I would like to use this code, to use the parser, which has got this read tree function, it's function from JSON. I just need to prepare instance of object reader, that's make reader function. It runs some stateful computation, and I have written mutable mapper because this, in fact, is tainted with this mutable data type, this label. And if I obtain reader, as you can see here, this function returns something immutable. So there is the mutable vanished. So we are ready to use it from Frege. And again, validate JSON is almost same. The difference is inside this case, between case and off. I just use this Frege function instead of function I had in wrapper. So we have JSON parsing done, and now we would like to make this web service. So again, two options. First one is that we call Frege from Java. This is first attempt. So some Frege runtime code is involved. This is this t-aider. That's the 3.23 version. So t-aider is not parameterized by type of left and right. It's improved in next version, which I hope will come soon. And so I just use ready Spark Java server, my code validate JSON, which is in a module I have somewhere else compiled before. I have this validate function, which returns either string with error or string with result. Some two other functions. This one is especially funny. It maps both either. In both cases, it maps the content. What is in case of left value, it applies identity function. Same with the right value. It's just for extracting string for our HTTP output. Status code will be either 400 or 200. Either takes functions as parameters, so I need to use const function instead of value. I think I won't run this code, and there is a better solution, of course. The ecosystem is growing. We have got JSON library, which is in fact ready wrapper for Spark Java, so the same server I used on the previous slide. And I will present this web service on 3 slides. First one is our main application, which creates some database table. That's some added value. I will store requests, and I just use this JSON library to have get handlers on 2 endpoints with this validate handler. Validate handler itself itself check if there is a body in the request. If it's missing, it returns 400 and there is no body response. Otherwise, it will try to validate JSON and return 200 code or 400 code with error message or a reformatted JSON. So this is quite simple, and code looks less like hello world. It's a code which in fact does something. And there is this database layer where I can create connection to database. It's I/O, it's a highly unsafe operation. I can log requests, so you can look at it and see how can JDBC inside Haskell look like. So that's it, and there is also function which drops table if it exists and creates one. This is made especially for presentation when I wanted to have a clear table. The example which I will run in a few seconds in fact uses H2 JDBC driver, so it's clean after restart anyway. So just to prove that this works, I will run this project. I use Gradle plugin. I have got 5 minutes, maybe 3, so I will say a word about plugins. It runs, and I have prepared URLs with invalid JSON, and server apparently returned 400 bad requests. There is also valid input. So we have made it, our first web service with Frege in 45 minutes or less. And I'd like to say just a few more things. I have used this Gradle plugin, which works, and there is also SBT plugin. There's a little difference because Gradle compiles Java first, while SBT compiles your Frege first. But I think that the best thing to do is to have separate modules and depend one on another. So I think it's cleanest way. There's also line plugin and line template for a quick start. I have used it also. It works. IDE support. I have used IDEA to show you code, but IDEA plugin is very poor, but you can upvote it. I would like you to do if you can. There's Eclipse plugin, which is useful. It's used by the compiler and core libraries developers. So Eclipse is ready for use. The community of Frege, it's quite small now, but very kind. I have got involved in project, I don't know, maybe 6 months ago, and I think people there are great. You can join us on Gitter, on IRC, which is connected to Gitter via bot. You can use mailing list, check on Stack Overflow, ask for help. Contributors are welcome, and I think because this project is there are many things to do on different levels. There are simple things, simple tasks, which should be done, like providing some type classes missing from Haskell report. But you can also dive into another things. For example, multi-parameter type classes are missing. So this is something really hard to do, probably. And links. First one is about these type annotations you could see in these Java sources, these annotations. If you would like to understand what's there, you should probably read this Practical Type Inference for Arbitrary Ranked Types paper by Simon Peyton-Jones. Learn your Haskell for a great good. If you are going just to start with Frege, I think it's best to start with some good Haskell resource. This Learn Your Haskell for Great Good, it's a very good choice for first book to read on Haskell. Haskell Report 2010, I have mentioned defined standard, and there's link for my GitHub where you can download whole presentation, and there is more code I didn't show because of time, of course. Do we have any time for question?
Yes, 2 questions, if there are any.
Yes?
There is a question, please.
Oh. I did not. There was one guy who reported on. Question was about if it's used in production. One person reported on Twitter that he does, and it was a few months ago. I cannot do it personally, but I think in some you could run some your helper services using it to try, and there was. Yeah.
What about the performance? Did you measure it?
Question is about performance, so I didn't measure it. Question was related compared to Java. So Frege is compiled to Java, so obviously you can write everything at least at same performance in Java. So you cannot have better performance than Java code. There were some examples, some tests conducted with Haskell code, and it turned out that it depends on case. Sometimes it's faster, sometimes it's not, but there was within 2-3 times slower or faster. But sometimes you gain if you compare to Java. For example, this lazy evaluation can be very helpful, and you won't write this by hand, probably.
Okay, thank you, Lech. And we have no more time for questions, so let's catch Lech afterwards.